Welcome back. We're in Giancoli Ch2 Problems, number 3. If you're driving 110 kilometers an hour along a straight road and you look to the side for 2.0 seconds, how far do you travel during this inattentive period? Well, cool. Let's first we got kilometers per hour. Wait, look at that. And I think about that and I go, oh, we did it for 2 seconds here. Well, if it wasn't kilometers per hour, let's say, what if our speedometer was weird or odd and measured it in kilometers per second instead? I bet that'd be a lot easier to solve for you. I bet you could do that in your head. Oh, well then if you recognize that, well, let's take 110 kilometers per 1 hour, the same way, same thing to write that thing. We go, hey, could I change that to kilometers per second? Oh, okay, cool. I bet you can. I'm going to go ahead and set up some dimensional analysis factors like you've done in chemistry. And you go, in 1 hour, I know that there's 60 minutes. Cool. And straight away here, I'm going to cancel out the hours, numerator, denominator. Units cancel just like numbers. But now I'm in kilometers per minute, so let's go ahead and let's do that one more time. And I want to get rid of the minutes, so I know that they're going to go over here. And I know how many seconds are in a minute. I chose seconds down there. I know there's 60 seconds in a minute. And I chose seconds down there because that's what we're trying to get to kilometers per second. And so now I have exactly what I need to do. I need to take 110 times 1 times 1, that's just 110, and then divide it by 60 times 60. 60 times 60 is 3,600. So I have 110 divided by 3,600. I go grab my calculator, and I find that it's 0.305 repeating kilometers per second is how far we're going. Cool. But now we're doing it for 2 seconds here. Well, that's pretty easy then. So we have 0.305 repeating kilometers per second. And now if I go and multiply that by 2.0 seconds, cool. Check that out. 2.0 seconds, I could write it as a fraction if that helps you out. I go seconds and seconds cancel out here. And now I'm just going to get the actual distance here. And I get 0.61 meters. And I'll just go ahead and round it to that thing. Now, we can go and verify this in a couple other ways here as well. We could go and graph it. I think it'd be a little bit harder graphing. We could actually look at the straight base formulas here. And notice that's actually what I'm doing here in the background is actually using some formulas. So let's take a step back since this might be the first time you're doing it and look at that again. I know that velocity here is some displacement over time. Another way to say that is it's some change in position over time. Okay. I also know that a speed is a distance per time, and we don't have fun abbreviations for speed and distance because we don't use them as much. Now here we're driving along a straight road, so that's really a speed that they gave us there. But it's going along a straight road, so I kind of know the direction because it's just going one direction. And so now if it's just going one direction, I could actually say, well, I know its velocity. Its velocity is just that number and in the same direction, not changing. So I could actually go and interpret this as velocity. Now, if I know the velocity, I know it's 0.305. Oh gosh, I wrote that wrong. 0.305 repeating kilometers per second. And that's equal to some change in position per some time there. But wait, I know that time. I know that time is 2.0 seconds. Now I'm going to go and multiply both sides by 2.0 seconds, and I find how what the change in position is, which in this case we're going the same direction, so it comes out to be the exact same thing as distance, and it's 0.61 kilometers. Cool. And that's it. Have a wonderful day.